welcome back to another video of LeetCode Daily Challenge Streak series, and in today's video we have a new question that says find the town judge. In a town there are n people labeled from 1 to n. There's a rumor that one of these people is secretly the town judge. If the town judge exists, then the town judge trusts nobody. Everybody trusts the town judge except for the town judge. There is exactly one person that satisfies properties 1 and 2. You are given an array trust where trust of I is equals to AI, BI, representing the person labeled AI trusts the person labeled BI. If a trust relationship does not exist in trust array, then such a trust relationship does not exist. Return the label of the town judge if the town judge exists and can be identified, or return -1 otherwise. So it's very simple, guys. You'll be given a set of arrays. Okay, let's assume it to be 1, 2 and 2, 3 for now, and another example being 1, 2 and 3, 2. Okay, let's first consider this example. So you'll be given array of arrays such that in each array the first index, that is A, shows that this A is a common person and thus A trusts the judge. Okay, for this particular array 2 is the person that one trusts. Okay, and for this particular array 3 is a common person and 3 trusts 2. So if you carefully observe here, 2 is being trusted by both these people here. 2 is being trusted by both these people. It means that 2 is the judge. Okay, 2 is the judge. Now, you might encounter a situation where you will have something like 1, 2, 1, 3 and 3, 2. Now, look here. Here, 1 is trusting 2 and 1 is trusting 3 as well. So, who is the judge? We don't know. Now, let's check the next one. So, here 3 is there and 3 is trusting 2 again. Okay, 3 is trusting 2 again. So, if you go back to the question and see, everybody trusts the town judge. Okay, so if there are elements like only 1, 2 and 3 in the village, 1 and 3 seem to trust 2. Correct? Seem to trust 2. Though 1 trusts 3, 1 also trusts 2. Correct? So 2 will be our answer. But if it is something like 1, 2 and 2, 3, you carefully observe that 1 here trusts 2. 2 here trusts 3. But 1 does not trust 3. Correct? Or 2 does not trust 1. Correct? So no number is being trusted completely by all the elements. Okay, no number is being trusted by all the elements. If you see here, this 2 element here is being trusted by all the elements. Here it's not being trusted by any element. Now let's consider a different example here. So we have 1, 3, 2, 3 and 3, 1. Now here 1 is trusting 3. Okay, nice. Next 2 is trusting 3. Well and good. But 3 here is trusting 1. Until now 3 was trusted. But suddenly 3 is trusting 1. If we assume that 3 is the judge until now and see that this judge is trusting 1, you can see that the town judge will never, okay, the town judge will never trust another town judge. So here this condition has failed. So we can't see any element that trusts one town judge. So we'll be returning -1 in that case. Okay. Now, what can we do here? It's a very simple math problem. Now the question says that each and every person trusts at least one person if there should be a trust judge or town judge. Correct? So if I have elements like 1, 2, 3 and 4, and let's assume 1, 3, 2, 3, 3, 3, no, 4, 3 and 5, 3. Okay, I have elements up till 5. Now if you can see, 1 here trusts 3. Okay, 1 here trusts 3. Okay, now 2 here also trusts 3. So what I'll do, every time some element trusts a number, I will increment the count of this particular town judge. Okay, so first initially all my elements will be equal to 0. So here when I come across the first situation, 1, 3, 1 is trusting 3. So someone is trusting 3. So what will happen, instead of 0, I'm incrementing the count. Okay, now one person is trusting 3. Now next 2, 3. someone else is also again trusting 3. Okay, so again my count will increment to 2. Now 4 comma 3. Now again someone else is trusting this particular town judge, so the count will increment to 3. 5 comma 3, again somebody trusted, so count will be incremented to 4. So if you carefully see, if everybody should trust a particular town judge, what will be the answer? It means that if there are n people here, okay, if there are n people, if you remove the judge count, there will be n minus 1 people who is supposed to trust the town judge, correct? If there are n people in total, and if you remove the town judge, you will have n minus 1 people. So you have to make sure at least one element in this particular array has a count of n minus 1. So when you are incrementing the count of trust here, in the end you are supposed to check if at least one element has a count of n minus 1. What does it mean? It means that at least this particular element has n minus 1 trusts. Okay, n minus 1 people trust that particular element, which means that everybody trusts except for its own element. Okay, if you iterate through the array and if you find no element to have a count of n minus 1, okay, if no element has a count of n minus 1, it means that not everybody trusts that particular person. It could be n elements also. 3 could also trust 3. Okay, there could be a case where 3 comma 3. But what's the point? If 3 comma 3 is there, the count here will be incremented to 5. Okay, the count will be incremented to 5. But what does the question say? It says that the town judge cannot trust himself. Okay, the town judge cannot trust himself. So the answer cannot be n. So the answer definitely should have only n minus 1. Okay. If and only if n minus 1 people trust a particular element, you are supposed to return the index. So what will you do? You will take an empty array, okay, and keep updating the counts of the particular value. So if you have 1 comma 3, 2 comma 4 and 4 comma 5, okay, what will you do first? Let me take an array. So 1, 2, 3, 4 and 5. Okay, so I have 1 here. Okay, 1 is trusting 3. So initially it was 0, now it becomes 1. Now 2 here is trusting 4. Okay, so initially 4 was 0, now again somebody is trusting 4, so it becomes 1. So 4 here, okay, 4 is trusting 5. So initially it was 0, somebody is trusting. Now we are done with the iterations. Now how many elements do we have? We have 1, 2, 3, 4, 5. We have 5 different elements, correct? We have 5 different elements. So we should have at least one element where n minus 1 elements are present. Okay, n minus 1 votes are given, which is 5 minus 1, which is equal to 4. Now let's iterate through this array and see if there is any element that has the value as 4. Here it's 0, it's 0, 1. 1 is not equal to 4, no. So 1 is not equal to 4. 1 is not equal to 4. So there is no element which satisfy the element as the town judge. So here in this case, you will be returning minus 1. Otherwise, if you had a case where an answer was 4 here, you will be returning the index of that particular, if the value here is 2, say 1, 2, 3 and 4. Okay, 1, 2, 3 and 4. And if at index 2, it has 4 votes. Okay, it has 4 votes, as in 4 people trust this person 2. It means that this person 2 is the town judge. So you will be returning this index 2, who is the town judge. Alright. Okay, so let's quickly code this up. We have a function find judge given, n, and trust given. So trust is the array of arrays which we have to iterate through. Now let's first initialize an empty array named votes. Okay, named votes. Now since we'll be having the values from 1, 2, 3, 4. Okay, we have 1 trusting 2, 2 trusting 3. So what we will do, we will initialize an array of 0 for n plus 1 elements. Okay, n plus 1 elements. Why n plus 1 elements? Because if you initialize 0 to n, you have your indices starting from 0, 1, 2, 3 and 4. But if you want 5 elements, you want it to be 1, 2, 3, 4, 5. Because if you are at 4, you want to update the value of 4. If you want 3, you will have to update the value of 3. So when you initialize it with 0 into n plus 1, what happens? You will have an additional value 0 here, but it counts to nothing since you will not be updating the value. You don't need this anyway. You just need it for the array initialization purpose. So when you have 0, 1, 2, 3, 4, 5 like this, when you initialize this, so if there is 1, 2 here, so somebody trusts 2, so you will go to index 2 and increment its count by 1. Okay, now so what are we doing? For I in trust. Okay, for I in trust, what are we doing? Votes of I of 0. Okay, if this person is at this index, it means that he can't have a vote. Okay, he can't have a vote. So you have to decrement the common man's vote. Okay, you have to decrement the common man's vote. So what happens if you encounter this person here? You have to increment its count. So if it's the second index, so votes of I of 1, okay, plus is equals to 1. What are you doing here? If I have 1 comma 3 and 2 comma 3, my 1 here is a common person. Okay, so if it's 1 here, it can't be the judge, correct? So if it has, okay, if for example the votes value of 1 has been, if I have something like 2 comma 1 and 1 comma 2, now here my vote, the probability, the vote for this particular one element has been incremented to 1. Okay, initially it was 0 for 1, it was 0. Okay, now after I encounter the value here, it will be incremented by 1 and it will become 1, correct? Now if you go to the second element, you see that this person is a common person, correct? So it can't be a judge, okay? So what will happen? It can't trust himself, correct? They can't vote for themselves. So for that, what will you do? You will decrement it by 1. So it will become 0. Okay, they can't vote for themselves, right? So they can't trust themselves. So which is why if you see a value in the 0th index, you will decrement it. If you see it in the first index, you will increment the count because they are being trusted. If it is in 1, they can't trust themselves, which is why we are doing it. So for I in range 1 comma n plus 1. Why 1 comma n plus 1? Because you don't want the 0th index anyway. All you have to care is about 1, 2, 3, 4 and 5, correct? All you have to care is about these elements and the counts present at these elements. So you will need from 1 to n plus 1, which is from 1 to 5. You don't need the 0th index. What are you doing after this thing? You're checking if the value is n minus 1. Okay, if votes of I equals n minus 1. If at some point I have a number where the votes, okay, the number of people that trust him is n minus 1, I will return the index of it. Okay, I'm going to return the index of it. Now after performing everything, if I didn't still find my I will just return minus 1 because I didn't find my value. Okay, let's quickly run the code. Accepted. Let's submit it. Alright, this works. What is the time complexity here? Since we are iterating over n elements, okay, to check if we have n minus 1 element, the time complexity would be O of n. Okay, likewise, we are also taking a vector for n elements to store the votes, as in how many people trust this particular element. We are taking the size of n elements. So the time complexity is O of n and the space complexity is O of n as well. Okay, thank you guys.